All right, if you remember our Gaucho example from class, we discussed how Gaucho was going to deposit $1,000 into his account every year at 6% interest compounded annually, and we calculated using our compound interest how much he would have in his account at the end of the 5 years. So we remember he deposited $1,000 after that first year of saving, and we knew that he was going to earn a certain amount of interest on that $1,000 using our compound interest formula of 1 plus 0.06 over 1 to the first power, right? And he was going to get interest, that amount of interest, how many different times? Well, he was going to leave that amount in the account for 1, 2, 3, 4 years, right? So he was going to earn that interest on his account on that $1,000 for 4 years. So can I say 1,000, he was going to earn this amount of interest on that $1,000 4 different times to the 4th power. He deposited another $1,000, remember, at year 2, and he was going to earn that same interest rate on that $1,000 for 1, 2, 3 years now. So 1,000, he earned that same interest for 3 years. At year 3, he deposited another $1,000, again earning that interest for 1, 2 years. He deposited another $1,000. He earned the interest on that account for 1 year. And at the end of the 5th year, he did deposit one more time, $1,000. In the end, it obviously didn't earn any interest, but it is still calculated into his total amount, right? If I were to take these values, I have 1,000 here, I have 1,000 times 1 plus 0.06. If you were to put that in your calculator, you end up getting 1,060. If I were to take 1.1 plus 0.06 squared, multiply that by $1,000, you end up getting $1,123.60. If I do it again for this next term to the 3rd power, you end up getting $1,191.02. And if I do it one more time for this last term to the 4th power, I end up getting $1,262.48. If I add all of these up, I end up getting a final amount of $5,637.10, which, if you recall, was the correct answer of how much money Gaucho would have at the end of the 5 years in his account, right? Well, if you look back at these sequence of numbers, and you recall back from our geometric sequence talk, that we have kind of an initial amount right here, this $1,000. Could I call that kind of like an A sub 1 of first term? And then I added to that first term that same amount times a certain value, or our common ratio, we called it R. And in our next term, we added that initial amount times that common ratio again, squared. In our next term, we had our A sub 1 times R to the 3rd. And in our last term, we had that A sub 1 times R to the 4th. Doesn't that kind of follow our geometric sequence formula? So then if I were going to add all these values together, could I use my geometric series formula? My first term times 1 minus R to the n over 1 minus R. Could I call my first term in this Gaucho example 1,000, which is the same amount as his yearly payment, right? Can I call that P, just to kind of generalize it, P for payment? And then I can call my common ratio, what did we multiply every single term by? We multiplied it by that common ratio of the 1 plus 0.06 over 1. That was my interest rate every single time, right? So can I generalize that and call this 1 plus r over, and that 1 was the number of times a year it was compounded, um, so it was annually, so once a year. So putting this all together into our geometric series formula, I can say that my a sub 1, or my p, my payment, times 1 minus r, my common ratio now, different than interest rate. I know it's kind of confusing to go back and forth between the different variables, but this is my common ratio, which was our 1 plus r over n. And now we want this n, which is the number of terms. Now, we did it annually for 5 years, we had 5 terms. But if we did it semi-annually for 5 years, how many terms would we have?